Let's learn the introduction to artificial intelligence today. Hey, welcome back to the AI introduction class. Today we will learn about neural network. In this class, we will learn the concepts, history, and the compose of neural network. Now, let's have a short introduction to neural network. A neural network, also called an artificial neural network, is a neural network of many interconnected neurons that simulates and simplifies the human brain. It applies some basic characteristics of the brain to create an abstraction and simulation of its functions. The idea of neural networks was first introduced in the 1940s. But it wasn't until the 1950s and 1960s that researchers start to develop more advanced models. In 1958, Frank Rosenblatt created the perceptron, which was the first neural network capable of learning from data. However, neural networks lost popularity in the 1970s and 1980s. Due to difficulty in training and the adequate computational power to process large amounts of data. The 1990s saw a resurgence of neural networks. It's all due to more powerful computers and new learning algorithms. This led to the creation of more complex neural network architectures, such as convolutional neural networks and recurrent neural networks, which was widely used in today's fields such as computer vision, speech recognition, and natural language processing. In recent years, the development of deep learning has further advanced the abilities of neural networks, allowing them to process even larger and more complex datasets with impressive accuracy. So, what does neural network look like? Here we have a simple structure for you to interpret. A neural network is a layered structure composed of nodes or neurons that process and transmit information. The most basic type is the feed-forward network, which has an input layers, one or more hidden layers, and an output layer. A neural network is a computer model made up of many neurons. It has three main parts: an input layer, one or more hidden layers, and an output layer. The input layer is the first layer of the neural network. It receives input data from the external environment and passes it on to the next layer of the neurons. The hidden layer is a layer or layers of neurons located between the input and output layers. They process input data by computing weights and bias and use activation functions to convert it into output signals. The output layer is the last layer of the neural network. It receives the output from the hidden layer as input and outputs the prediction and/or classification results. When we start training neural network, here are several tips we need to keep in mind. First, get your data ready by cleaning it up and put it in a format that the computer can understand. You will want to divide your data into three parts: one part for the training your model, one part for testing how well your model works, and one part for fine-tuning your model. Second, pick a type of neural network that makes sense for your data and your problem. You will need to choose things like how many layers you want in your network and what kind of activation functions you want to use. And then choose a way to measure how good your model is doing. This is called a loss function. Different types of problems requires different types of loss function. Train your model by giving it the training data and having it try to learn from that data. You'll need to use a method called backpropagation to help your model learn and improve over time. Once your model is trained, you'll need to test it using the testing data. This will help you to see how well your model is doing and whether it's ready to be used in real world. Fine-tune your model by adjusting some of the setting and try it out again. This will help you make your model even better and more accurate. Once you're happy with your model, you can start using it in the real world. You will want to keep testing it to make sure it's still working well, and you may need to make some tweaks along the way. And finally, you will want to think about how you can make your model faster and more efficient so that it can be used by more people and in more places. Now, let's move on to see what is neurons and activation functions. A single neuron, also known as a perceptron, is one of the basic components of a neural network. It receives multiple input signals, weights them, and then pass the weighted sum through an activation function to produce a single output. Each input in the perceptron is associated with a weight that determines how much influence that input has on the neuron output. The neuron's output is calculated by summing all the weighted inputs and passing the result through the activation function. The activation function in a perceptron is usually a threshold function that produces an output of 1 if weighted input sum exceeds a specific threshold, and 0 otherwise. This simple activation function makes perceptrons mainly suitable for binary classification tasks, such as distinguishing between two different types of objects. In a neural network, the output of a single perceptron is typically passed to another neuron or connect to the output layer to produce the final output. Multiple perceptrons can be combined to form more complex neural networks to handle more complex tasks. While an activation functions is a type of long linear functions used in neural networks. Its purpose is to add nonlinear characteristics to the output of neurons, enabling the networks to process more complex data patterns. Common activation functions include the sigmoid functions, ReLU functions, and tanh functions. The sigmoid function maps input values to continuous values between 0 and 1, and is commonly used in the output layers of binary classification problems. The ReLU function outputs its input when the input is greater than 0, and output 0 when the input is less than or equals to 0. It effectively solves the problem of value gradients and is one of the most commonly used activation functions. The tanh function is similar to sigmoid functions, but maps input values to continuous values between -1 and +1, and is commonly used in hidden layers. Choosing the right activation function can help neural networks fit data better, improving model performance and accuracy. However, it is important to note that activation functions may also have some issues, such as vanishing or exploding gradients, which requires reasonable selections and adjustment based on specific problems. Now, let's move on to the loss function. Loss function is a reflection of how well the model fits the data. The worse the model fits, the greater the value of the loss function is. Mean square error is a pretty common type of loss function. The smaller the mean square error is, The closer the model's prediction are to the actual results. The loss function graph is usually a curve that shows how the model's prediction differs from the actual results at different parameter values. The x-axis represents the parameter values, and the y-axis represents the value of loss function. So that's what we need to learn today. In this class, we will learn the common algorithms for deep learning.